Let's look at domain and range of a relation. So remembering that a relation is an association between two sets of elements. The first set of elements is referred to as our domain. So we can call that, remember, our independent variable or our input values. Our range then is the second set of elements, or all of the possible values for the dependent variable or the output. So oftentimes we think about the domain as what are all of the x values, or the range as what are all of the y values. But we also know that sometimes we're not just looking at x and y. Now let's take a look at a couple of graphs then to help us to determine domain and range. So we can see in our first graph here, call that example 1. In this particular graph, we have a set of discrete points. So perhaps I can label my points, this one being -3, -1, because we write our x value first. This is -1, 2. This point here is 0, 1, and this one is 1, 4, and 3, 2, and 4, 2. So if I'm looking at my domain, the domain would be a set of, and we can take a look at all of my x values. So we have -3, -1, 0, 1, 3, and 4. And those are just all of the possible values of my x's. When I look at my range, and this second set consists of all of my y values, so that'll be -1, 2, 1, and 4. And so, again, we've talked about before, it's nice sometimes to have these in order, so maybe I'll change those around. So -1, 1, 2, and 4. There is no need to repeat values. If I take a look at the second set of values here, my relation, we again have some points, discrete points. So here we have -1, 0. We have the point 0, 1. This is 1, 2. And this is 1, 4. And this would be 3, -1. So my domain, once again, is listing all of my possible x values, or everything coming from the first set. So we have -1, 0, 1, and 3. And my range is the set that contains -1, 0, 1, 2, and 4. So this second example is very similar to the first, except what might you notice is that in the very first example we have this value, this y value 2, being repeated. Is that an issue? Not at all, because remember, when we're trying to determine whether or not a relation is a function, we're checking to see if any of the domain values are repeated. And when I look at my x values here, there is no repetition. Every single input that I put in comes out with a different output. Whereas if I take a look at the second example, every input, we can see here this input of 1 has 2 possible outputs, in which case we would say that the second example is a relation. However, this is not a function. When I take a look at my third graph, here we can see that it's no longer a discrete graph. It does have a distinct start and a finish as given by these dots, and so we do have to be careful with that. So let's take a look at our domain in this third example. So our domain, we can see that it's our smallest value is -4. So I'm going to start with my set brackets again, and we'll say that it's all x values such that -4 is my smallest value, and x values are greater than or equal to -4. And what is the largest possible x value that I have is 2. So x must also be less than or equal to 2. And since it's all possible values in between, we have a solid line going through. We know that x belongs to the set of all real numbers. Again, similar for range, we're looking at the set of y values such that, and the smallest possible y value is going to be 0. So then 0 is less than or equal to y, which is less than or equal to, and the maximum y value is 4. And again, because it's a solid line, y belongs to the set of, or is an element of, real numbers. If we take a look at this example, we can also ask ourselves whether or not it's a function. If I take a look at every possible x value, is it giving me a different y value? And the answer is yes. The other thing that we can see is the vertical line test. Is there any point where I can draw a vertical line through that graph where it will intersect at more than one point? And since the answer is no, it is in fact a function. Let's take a look at another example. We'll call that example number 4. In this particular case, I've graphed the function f of x is equal to 3x plus 1, and we can see that it is once again a continuous line. We've got arrows on either end. If we were to graph that on our graphing calculator, we can do that by turning it on, going to y equals, and putting in 3x plus 1, and then hitting graph, and it graphs it through. And obviously on our calculator we're not seeing arrows right here, but we know that if we expand the window, it will be continuous all the way through. So when we're determining our domain, then we're saying that once again it's a set of x values such that, and will there eventually be an x equals -5, -6, -10? Absolutely. And will it also continue into the positives? Are there any limitations? No. And therefore we simply say that x belongs to the set of real numbers. In terms of my range, again, we're looking at our y values such that y, and again, because there are absolutely no limitations, it goes on and on continuously in both directions. Y belongs to the set of real numbers. Let's take a look at example 5. So here we have a parabola, or kind of a U shape, and this one is defined by f of x is equal to x squared minus 4. We can also graph that on our calculator. Let's go back to our y equals, and we'll clear this one and put in x squared minus 4, and we'll graph that, and we can see that parabola in the same shape as we have right here. So in this particular case, when we take a look at our x values, again, our domain, will we eventually get to -10, -100, +10, +100? Can I find x is 0? Yes. And so there are absolutely no limitations for my domain, or my first set of values. And so once again, we can state that the domain is a set of all x values such that x belongs to real numbers. In terms of my range, though, what do we notice is that there is a limitation. And what do we know is that we will never see anything less than -4. So what do we know is that y must be greater than or equal to -4, but at the same time, it can be all fractions and decimals in between, so y still belongs to the set of real numbers. Let's take a look at a word problem. So we know that word problems could probably also be graphed as well. If you're looking at a situation where Jill is selling Girl Guide cookies for $4 a box, determine the domain and range. Well, first off, we need to think about what would be our independent or our first set of values. So our independent variable will be the number of boxes she sells. Right, so the number of boxes of cookies, and perhaps I'll name that B, and the dependent variable will therefore be her earnings then. And so we can call that E. And so what do we know about the number of boxes? Well, she can't sell half a box. She can't sell negative boxes. Could she sell 0 boxes? Absolutely. Conceivably, could she sell infinite boxes? Well, probably not. But for our purposes here, what we'll say is that the domain is the set of B values such that B must be greater than or equal to 0, and B belongs to the set of whole numbers. And really, when it comes down to it, we know that all whole numbers are greater than or equal to 0, so in fact we could even take this part out of it and just indicate simply that B belongs to the set of whole numbers. In terms of our range is our earnings, and again, what do we know about how much money she's going to make? Well, if she doesn't sell any boxes, she'll be making $0. Is it possible for her to sell negative dollars? Probably not. And is it possible for her to earn anything in between, any decimals? Likely not again. And therefore, what do we know about her earnings? Well, they'll probably be multiples of 4, but we don't need to be that specific. We do once again want to say that earnings are going to be greater than or equal to 0, and E belongs to the set of whole numbers. And once again, we could leave out the fact that E is greater than or equal to 0 because all whole numbers are greater than or equal to 0. So for practice, please complete these particular pages and numbers in your textbook. If you're finished with that, there is a booklet on domain and range that you can be working on.